Hey, and a wonderful good afternoon. Welcome to the discussion on ethical, societal, and environmental implications of information technology. My name is Tarek Besold. I'm actually a former Heidelberg Laureate Forum participant myself. Nowadays, I'm the head of strategic AI at DECRA Digital and dealing there mostly with questions very much related to today's topic, things like AI safety and AI security. Anyway, I'm actually only a side note to this entire event. The actual VIPs and main contributors are four incredibly bright people, and I'm super humbled and honored to welcome them here and to guide them and you through the following 60-ish minutes. So, introducing them, we have today Shafi Goldwasser, a Turing awardee in the year 2012. Shafi holds the RSA Professorship of Electrical Engineering and Computer Science at the MIT. She's a professor of mathematical sciences at the Weizmann Institute of Science in Israel. She's co-founder and chief scientist at Duality Technologies, and I somewhat suspect we might hear a little more about that later. And she's a director at the Simons Institute for the Theory of Computing in Berkeley. Her work spans a wide area, but trying to, condense it down, I'd say it usually revolves around the themes cryptography, number theory, complexity theory, and very much the applications thereof to, hands-on questions and security and privacy. Shafi, welcome. Secondly, we have Efim Zelmanov, Fields Medalist 1994. Efim is a professor at UC San Diego and a distinguished professor at the Korea Institute for Advanced Study. Among the many honors Efim received counts a fellowship of the American Mathematical Society, and what I found really remarkable, he's also a member of the American Academy of Arts and Sciences, of the Korean Academy of Science and Engineering, as well as the Spanish Royal Academy of Sciences. In his work, Efim mostly addresses questions in combinatorial problems in non-associative algebra and group theory, among others, solutions to the restricted Burnside problem. Welcome, Efim. Thirdly, we have David Andrew Patterson, Turing awardee 2017. Andrew is a professor emeritus of computer science at UC Berkeley and currently holds the position of distinguished software engineer at Google. Also, he serves as the vice chair of the board of directors of the RISC-V Foundation. You already now heard the word RISC, which is one of the main themes with which the name David Patterson is associated. So David was the leader of the Berkeley RISC project and thus one of the pioneers of the reduced instruction set computer architecture. And if you're wondering what it is, it's roughly 99% of all modern chips which are built on that architecture. Also, David contributed to the creation of the RAID storage approach. Welcome, David. And then, finally, we have Josef Sifakis, Turing awardee 2007. Josef is a professor at the École Polytechnique Fédérale de Lausanne, and he is founder and leader of the Verimac laboratory at the CNRS in Grenoble. Also, he served as coordinator of ARTIS-2, the European Network of Excellence for Embedded Systems, and among his many honorary titles count a commandership of the French Legion of Honor, as well as a commandership of the Greek National Order of the Phoenix. Joseph's contributions mostly lie in the field of model checking, which, and maybe we'll also hear about that later, currently sees lots of applications, for instance, in safety and security of IT technology. Okay, that's the four brilliant minds we have here. And I've brought many questions. I'm sure many of you listening in will also have questions, so please do contribute via Slido. But before then going into the Q&A, which will be at least the final 15 minutes, let's first have a bit of a discussion among the four of you. So, ethical, societal, and environmental implications of information technology. Shafi, knowing what you're doing and what you've done, What are your immediate thoughts when you hear the title? What is the relationship between information technology and ethics, society, and the environment? And why do you think we actually should look really deeply into that?
Okay, the first thing that comes to mind when I hear this title is the fact that the information technology, and especially these days, the availability of large data and machine learning has really altered the face of lots and lots of, in fact, every aspect of our life. Infrastructure, finance, medicine, the way we shop, the way we are treated by our doctors, the fact of whether we receive loans, and so forth, or even these days whether you're going to manage to get out on bail. So courts are using computers more and more in order to inform their decisions. Now, obviously, that means that our entire society, our set of basic values is being controlled by algorithms. And as such, we are really believing the power of statistical prediction, and we should be a bit, obviously, very careful how that meshes with our basic views of how society should run. So some of these topics are obviously societal, like deciding whether someone should go out on bail or whether someone should be accepted to a school. Some maybe less so, how the traffic, gets rerouted. But even that has huge implications on neighborhoods, whose neighborhood is going to have a lot of traffic, whose neighborhood is not, or using computers to schedule buses for having kids going to school. Are these algorithms fair? Are they scheduling the buses in a way that is equitable around society? So there's clearly a question of fairness, and there are questions of privacy, because with the fact that decisions are made by algorithms, it means that there's a power shift. And the power really belongs to whoever has the data, it seems, to inform their algorithm that would make decisions. So since the data comes from us, if we don't want to give all our power away, we need to find ways of protecting the privacy of our data and yet enabling progress. So I think the two topics are fairness and maintaining privacy of data so that we maintain control in some fashion at least.
Thank you, Shavi. There was a lot in there. You already mentioned several applications to the legal system in the medical context of information technology, but you also directly went for some of the key societal questions behind it. David, if I can also draw you into the conversation. So you are one of the pioneers behind a lot of the architecture, making IT as we know it now possible, and also the ubiquitous application. What are your thoughts on the topics Shavi just opened?
Yeah, the reason I volunteered for this panel is in the last year I got involved in the environmental impact of machine learning. I think all of us are concerned about global climate change and what it's going to mean for our descendants and what kind of world we're going to leave behind. So because of as Shafi suggested, there's this tremendous excitement about machine learning. And then recently there's been concern about the impact of machine learning specifically, and then maybe the cloud in general, or just all of information technology in terms of its environmental impact, and particularly CO2 emissions. And what I saw was, concerned, well-meaning people trying to guess what that impact was, speculating what that impact was. So I think at least for those of us living in the United States, it's really important to get facts, right? In this modern world, perhaps empowered by the internet, there's arguments over what are facts. Ideally, everybody shares facts and has their own opinion, but these days it seems like people are having their own facts. So I tried to, with some colleagues at Google and Berkeley, to try and get facts on the issue about machine learning. In particular, there's been a lot of excitement within the machine learning community about these very large models. The most famous one that made the newspapers about a year ago is called GPT-3. It stands for some kind of bigger transformer. And kind of the big idea of GPT-3 over the people who did this work at OpenAI over GPT-2, its predecessor, was that it was bigger. It was about a factor of 100 bigger in terms of measurements like the number of parameters. So what does that mean in terms of the environment? And so we did a paper in arXiv that looked into that. We looked at some previous claims, and unfortunately, because they were done retroactively without the participation of the authors, they were off too high, about a factor of 100. So I'd say I think as citizens of the world, we need to be careful about the technology we're making, but we also, as scientists, need to get the facts right to make sure we're attacking the right problems. So I think that's what my interest is in this panel. And it does feel like it's an ethical responsibility to be, as developers of technology, to make sure we understand the environmental impact of what we do.
Quite some additional very important points you added there. I actually want to add one more, and I'm then looking towards Joseph to share his thoughts on it. Namely, both David and Shafi both mentioned machine learning as a technology that's more and more used, and models which are growing and growing. So at least in the past, we thought that as users, we would have control over the technology we use, and that we could, well, reasonably certainly show that the technology is safe and controllable. So verifiably so. You've been working a lot on model checking, and one of the applications of model checking, if I'm not completely mistaken, at least in the software context, would be to show what properties a system has and what it doesn't have. For all I understand, machine learning and large models push this to the, well, to the very edge of what's still feasible. What do you think about control, technology, and what we do with it these days? Joseph?
Yes. Okay. So model checking is about checking models of systems. And the problem with AI is that it's not explainable. What it means, it is not explainable. As a rule, we cannot find the models. So machine learning techniques are based on training a neural net. Okay? So it's by learning, we cannot have neural
Joseph,
nets.
Joseph, can I briefly interrupt you? Joseph, it seems we have a slight problem with your connection.
And you cannot predict it.
Joseph, it seems we have bandwidth issues with your connection.
Bandwidth issues. Okay.
Yeah, let's try again. Now you seem to be back.
Okay, now I'm back. Okay, yes. So I was saying that AI is not explainable, so we cannot reason about AI systems, and we cannot provide the transportness guarantees as we can provide, for instance, for, I don't know, a flight controller. I have worked with flight controllers and safety critical systems. If you have models, you can evaluate reliability, and you can say that, say, a flight controller has a reliability of 10 to the minus 9 failures per hour of flight. So based on some reason, we cannot apply this type of reasoning to AI systems. And that's the problem, I think. And AI will not be explainable I mean, there are people working on that, but I doubt that AI is explainable. Just because machine learning systems deal with concepts that cannot be formalized mathematically. For instance, if you have a neural net that distinguishes between cats and dogs, how you can formalize what is a cat and what is a dog? So this type of systems will remain not explainable forever. And the issue, of course, is how you build the reliable systems with non-reliable components, which is an old problem in systems engineering. And this is a problem I am working on. This is very challenging, I think, but we should continue working at that.
Yeah. Yeah, no, most definitely. Like, if the alternative is to basically regress in technological state and the benefits of it, or to try to solve hard problems, I think the four of you are perfect examples that perseverance actually pays. Efim, I'm looking towards you to open yet another line of conversation, and then I'll actually more or less hand over to the four of you to pick which one you want to follow. You are moving between at least two cultural contexts. So you're a professor at UC San Diego, but also you got close ties to the Korean Institute for Advanced Study. The entire debate around responsible tech or trustworthy tech also has strong cultural components and will impact different areas of the world differently. What is your view on how do you experience it? Or do you actually see signs that different cultural circles do approach it from different angles?
Well, I'm indeed, while I work in United States of America, I'm deeply connected to Russian culture, Korean, Chinese. But science is what brings people together. I don't see any cultural differences in approaches to science in any of these countries. There is no, say, American mathematics or Chinese or Russian mathematics. There is just mathematics, which is done in different countries.
Which is actually a beautiful point in that, at least I personally believe that trying to solve the questions we're starting to discuss here in a geographically restricted way or in an insular way won't get us far, precisely because they are, as you just pointed out, deeply rooted in science, and science is a universal language. Still, I actually want to come back to the topic of trust and control in technology. So both you, Shafi, and you, well, actually all of you, shed light on it from different sides. Shafi, you've been doing a lot of work in cryptography and related to data. Can you give us a picture of how you would see that science and the tech we are building can contribute there in safeguarding the reasons to trust systems?
Yeah, but I want to make a point about the last speaker, about societal issues, whether they're relevant to the kind of science we're doing. And I certainly don't think they're relevant to how we do the science, or what is a correct theorem or what isn't a correct theorem. But I think it is relevant to the questions we study. So just some examples. With COVID, there's the whole issue of contact tracing came up. And in some societies, like in Israel, contact tracing is done and nobody actually doubts it. So in other words, people can tell who you've been near, and in order to contact them and let them know whether they should be quarantined or not. And this, they were using technology that was in a military context. But I don't think the public, maybe there was awareness of it, but nobody thought that they would stand the chance to restricting it, in my opinion, for good reason. But it doesn't matter. The issue is, for example, in the United States, the issue was addressed very, very differently. So I guess my point is that what you choose to study is different depending on what the society cares about or puts more impact on, or the safeguards. Another example is privacy. So there it goes the other way. So there are very strict privacy laws in Europe, which enforce fines, let's say, on large companies, and fairly serious fines if certain privacy regulations are not followed, or you can find out that they were not followed. And now, because of that, the industry in the States followed suit because they want to be able to sell in Europe. So I think that societal values or norms do affect laws, obviously, and they do affect what people choose to work on, and that at least in computer science. In mathematics, less so. But in computer science, which is right out there and being implemented, new questions come up depending on how the society rules. So if there's a certain policy about privacy, how do you actually build a computer system so it adheres to the fact that no personal information should be derivable from public record? Or, we're talking about courts. The whole idea that bail is decided, there's cash bail in this country, brings up the question that you want to go from cash bail maybe to bail decisions which don't involve cash because that's unequitable. And now you have to address the fact, how do you use data from the past to make good predictions about whether you should release someone on bail or not bail, which is very interesting statistical questions, because you could never really have a controlled experiment with the same person, whether they went out on bail and committed a crime or they weren't let out on bail. So how do you statistically make inferences which are going to be good for the future? So I guess my only point here, which I completely forgot what you asked me, because my point is that the values, especially on topics like ethical and societal values, which is what computer scientists in this field are working on or should work on, are affected by the reality on the ground. What did you ask me?
Actually, Shafi, never mind the question. Never mind the question. I'd actually rather want to see whether one of the gentlemen wants to reply or add to what you just said.
Yeah, I certainly, I think of computer science as at this intersection of engineering and science. And I think both of us are at Berkeley. Shafi's a little closer to the science, I'm a little closer to the engineering. And one of the challenges in academia is picking problems that are really important. It's pretty easy in academia to pick problems that, when you look back 20 years later, didn't matter very much. So I think in the engineering side of things, absolutely societal issues affect the importance of problems, or affects the solutions that you come up with. China has a lot less issues around privacy than the United States does. So I think it's certainly Shafi's work, is around cryptography is incredibly important in the United States on the protection of privacy. I would think in countries where privacy isn't one of the rights, it wouldn't be as important, and it would affect what people work on. So I think of, where scientists emerge in societies, and the laws and the cultures there strongly affect, at least for computer science, what we work on. And I think that's why I think this is a reason we're having this panel, is the societal concerns of people monitoring us, what's happening to our environment, and shouldn't the training that we do. It seems compared to when I was an undergraduate half a century ago, we talked about ethics a little bit, but it seems the pervasiveness of our technology and what's going on in society means it's kind of needs to be part of the training that are coming up here. Students graduating now will be put into situations at some of these at unnamed companies that are affecting billions of people, and could put lives at risk, or have them be hoodwinked by criminals and stuff like that. So I think maybe it's because of the pervasiveness, is that I think ethics is even more important to be part of the education process today than it was in the past.
Joseph, I think you wanted to come in.
Yes. Okay, let me be a bit provocative by saying that privacy is a lost cause. And I have an engineering background, an engineering approach, and there are properties you cannot formalize, you cannot capture globally, and that's the problem. You can talk about privacy, but what is privacy? What it means of course, you can try to protect data, but you have phenomena where so big companies collect data. I think there are some subtle and pernicious dangers from the uncontrollable use of what we call for instance, reputation systems that are systems that collect data and about an entity, and the data can be used to characterize and predict the entity's behavior. So the entities can be institutions, can be individuals, and we know that these reputation systems can be used to build social credit systems that can establish a kind of record system that can track and evaluate the trustworthiness of the entities. So it's a kind of point system. And this cannot be controlled, in fact, because, for instance, so in social media, users people use services that are for free. They provide their data, and by collecting pieces of personal data, you can build a profile of a user, and nobody is aware of that. So you need some very strict regulations about the use of this information that do not exist today. So I believe that privacy will be a problem and cannot be resolved.
Yeah, good point there. Shafi.
Yeah, so I think it's extremely important to define, of course, what you mean when you say the word privacy. And the word privacy is thrown around too loosely. But there are topics that, informally, are contingent to the word privacy that can be defined precisely and addressed. So I just want to give an example of something that you could have thought, well, I give up, there's nothing to do, but you can do something meaningful. And it actually touches on David's environmental issue. So if you think about blockchains, they're really changing the financial system now, and cryptocurrencies and so forth. The original Bitcoin model, and still the way that Bitcoin works, worked on the technical premise of proofs of work, where in order to post a transaction on the blockchain, whoever put more computing power sort of won and could put their transaction before somebody else's. That is a tremendous waste of energy. There's farms and farms of computers working on wasting energy to establish another transaction on the Bitcoin blockchain. So there is a problem there. Do you just say, well, that's how blockchains work? No, these days there are other protocols that have to do with consensus in order to agree what the next transaction on the blockchain is. And they don't require a lot of energy, and they don't require this competition with more computing power in order to achieve a transaction. My point is that I think that if we focus our attention on realizing what the problems are and defining them, and then you can also address them. So to say that privacy, that the genie's out of the bottle and there's nothing we can do, I cannot disagree with it more.
Yeah, so a question from the sideline. I think it also has been said before, regulation is needed, but the question then still is enforcement, right? Like, regulation only works if there is a benevolent regulator enforcing it. What is the relationship between, say, governments and their different, and there we're back to somewhat worldviews and cultures, governments, companies, individuals, and the technology we are building? Does any one of you want to say something to that? How do you regulate and enforce IT?
I don't think there's a problem.
Okay.
There's people are regulating kind of interestingly. When I joined Google 5 years ago, I think the image was, oh great, what a wonderful company, I use their products all the time. And today around the world they've come up with the name big tech, which big is bad apparently. And and so-called big tech's being attacked in the United States, in Europe, and in China simultaneously. It's hard for me to see what's going on today, even though I'm associated with one of these companies, and say, wow, government has no power to control big tech. It looks like it's got a lot of power to control what's going on. There's laws being passed in Europe, and like Shafi said, because these are all international companies, if a law is passed in Europe, it affects these international companies, and they around the world, they're being sued, they're being fined. There's legislation being considered in the United States, I think the person that the Biden administration picked to be the antitrust czar had formally sued Google several times as when he was a lawyer. So I don't have the feeling that governments are powerless in the face of big tech, based on what I'm seeing. And I just wanted to add to what Shafi said about Bitcoin. It's a terrible technology. It's awful. And I think whoever invented Bitcoin just didn't have the technical background or the ethical training to think about, if we're successful, what's the impact of this going to be? Right now, Bitcoin uses up the mining and the verification of the transactions. It uses up more energy than Argentina this year. Every kind of transaction, if you use a Bitcoin instead of a credit card, it uses up almost 1 million times as much energy. So it's just it's a great, terrible example of technology. And if we could go back in time, we could be doing something that would be tremendously better for society. It's the worst case example. It's such a bad example. When I used it in my paper to talk about ML, they said, "Oh no, you can't use that example. It's so awful. Everything looks good relative to it." So that's an example of mistakes we can make. I'm hopeful there'll be examples of good things that we can do.
Thank you, David. My question actually was a bit of a segue already to, 1 second, please, was a bit of a segue already to one point from the Q&A. We have one question there, which I now already want to throw in. Who should be taken responsible for the ethical impact of technology? Programmers, companies, governments? I think quite some of it was already in your answers before, but who is responsible for the ethics, in your view?
Can I give an answer?
Yeah.
It's obvious. It's governments, it's institutions. They define the rules of the game. They are responsible for that. Companies are not responsible. They have to follow regulations and rules. And as long as governments, agencies, institutions do not enforce some rules, there will be a problem. And I can talk about the area I'm working on. It's autonomous vehicles. The area is not regulated, and if you see that the behavior of the agencies has changed. These are critical systems. A self-driving car is a critical system, but there are no rules. And what they recommend is self-certification. Self-certification means that the manufacturer guarantees that the car is good enough, is safe enough. Okay, and this is because of lack of regulations or restrictions about how to use the cars. These are very well-known facts. I don't think, and self-certification now is applied in the United States in aircraft, in automotive, and also in medical devices. Okay, FDA applies self-certification. So this is a problem for me. We should not be permissive. We should not, of course, the argument is that they want to encourage the advancement of technology, of course, but there should be limits, and the limits are defined by the fact that humans are the supreme value, okay? For me at least. So, and human life, okay?
But how do you then solve the after-the-fact problem? So regulators react. Take the Bitcoin example given before. So I very much appreciated the statement that whoever came up with the way Bitcoin originally started probably lacked the technical skill to build it in a, less expensive and environmentally impacting way. So do we always have to play the catch-up game, or might there still be a point in actually trying to directly address the people building the tech, and then we're back to us as scientists?
Go ahead, Shafi.
Okay, so just a quick thing. I think that playing the catch-up game is not the end of the world. So in other words, a lot of progress happens this way. We don't know all the unintended consequences of what we do. as David said, we should make sure that now computer scientists, at least, and engineers, obviously, when they're trained, they should also always think, what is the possible consequences which did not intend of their invention? It's an interesting exercise, but even if you do it extremely well, you're not going to be able to predict the extent that your work is going to be received and maybe put into practice, and then what consequences you would have. So the catch-up game is inevitable, in my opinion.
Other voices to that?
I was just going to say that. Go ahead.
Go ahead.
Okay. Well, I agree that I don't think it was a responsibility of the inventor of Bitcoin. It's just a paper. The responsibility was with the governments. And governments, I'm afraid that not all governments lived up to that responsibility.
I did some work in biology with computer science and biology a little while ago, and I was able to contrast the two fields, and it was amazingly different cultures and what they valued, what we valued, and what they valued. But one thing that biology I thought did better than we do is if they had a technology that could have far-ranging impact on society, they would pause that technology and get the leaders in the field together, along with medical ethicists, and kind of come up with a game plan. So that's, I think, happening right now with the CRISPR technology, and it's happened in the past where they've paused before they've gone ahead. That's certainly not the tradition in our field. Our field is, get things out there quickly to do that. I do wonder, like there's been articles in the New York Times about Facebook as one of the big tech companies, and they talked about there was presentations leaked that were given to leadership at Google about the impact of some of their products on teenage girls. Like for 1/3 of teenage girls, it made them feel bad about themselves, what this product was doing. And I think what we've seen sometimes in tech is people, quitting the company because they disagree with the policy of the company. And so I think ketchup is pretty inevitable, but I think there'll be times, I think, you may end up in a situation where you're going to have to decide whether you're going to keep your job and go along with something, or decide that you think this is the wrong thing we shouldn't be doing this, and that you should protest and then possibly resign. I think that's a relative, like I said, 50 years ago, it was hard to imagine that was going to happen, but these days it's pretty easy to happen. So I would like to think that if we had point that out to undergraduate students, this could happen in your career, then that would help ameliorate some of the excesses when in the cases like Shafi talked about, when we can see the impact of it.
Yes, but you cannot hold the responsible, I don't know, the engineer who builds, say, self-driving cars for self-driving cars not being safe enough. Okay, I mean, this should be defined. I mean, the issue of safety or trustworthiness should be regulated somehow. And the problem is that
I agree with you.
You agree. Okay.
There should be regulation for sure, but I think there could be situations as an engineer when you're developing the technology that you can see the weaknesses in the technology. That I think a specific example along those lines, as I understand it, I own a Tesla car which has modest self-driving ability. I believe Google was pretty early in the self-driving thing, and what the product that Tesla provided was kind of drive on the Interband or on freeways driving, with doing a lot of the driving, relying on the driver to take over if anything got difficult. And there's danger in that technology because the driver could be distracted or reading a book or something and take over. So I think Google, along the way, could have developed that technology and put it out there a long time, way before Tesla. But I think the engineers involved decided that wasn't good enough. This is my guess. That why didn't they make a product out of it? I think they decided that was just too dangerous. That drivers wouldn't pay attention. They would rely on the technology too much, and people would die. That's my guess of what happened inside Google. So they went for the full self-driving. Now, full self-driving is really hard. I don't know if we're ever going to get there, but that's what they decided to do. Now, whether that was a bad business decision or was an ethical decision, it's hard for me to know. But I think I'm hoping, maybe optimistically, that engineers thinking about ethics may influence what kind of technology we build, in addition to the government ensuring that we don't do bad technology.
So, David, quickly coming back to the comparison you made before to biology and the biomedical fields. One of the particularity there is that very often, before you're allowed to do an experiment already in your bachelor's or master's, you have to go through an ethics committee approval. So you're much more used to institutionalizedly think about that. This far, we often argue that in our field, because we do not touch life as such, but we are more structural sciences, or however you want to call them, we wouldn't need that. And lately, a few conferences in computer science started to introduce ethical statements as an obligatory part of the submission there, and it caused, say, divided opinions. Do you think that, and this is also a question from the Q&A already, do you think computer science professors or computer science courses should be required to discuss about ethics? And if so, are they qualified to do that?
I want to say something touching on the self-driving cars, just explain how difficult a challenge it is. So the things that came up are things that you can understand, but safety is something that we've talked about in our society. But suppose you have a self-driving car and it realizes, just because of all the examples, that if a woman is driving, it's easier to cut, okay? Because they're more cautious drivers. So they don't know that they're realizing it, but that's the case. So if you identify that the driver in the other car is of a particular gender, you might have a different driving strategy. So we roll this, suppose this happens 10 years down the line, all the women are getting to work slower because they're being cut all the time. So this is a kind of futuristic unintended consequence that is hard to anticipate to begin with. So I guess my point is that with all good intentions, it's going to be difficult. And maybe the example of the women driving the car, if anybody would put it under an umbrella that's being studied today, is this field that's called fairness. Okay, so it's like a general definition, and it might capture this particular special case. So I would say that the emphasis is on general definitions and trying to go more mathematical, actually, to prevent these type of issues. That's one thing. And to your question, no. The idea that every class would require ethics, we have too much material to teach. But the idea that there is, like maybe it's a requirement, write a paper on one unintended consequence you can imagine and what you would do about it. But an important, worked out paper, not some superficial thing. Something where you think about it and you engage in it, that might be a good addition to an undergraduate education.
Yes, but there are things that cannot be formalized, and that's the problem. And intelligence systems deal with concepts that are not formalized. If we want to have machines that compete with humans in intelligent behavior, we have to accept this. There are limits to formalization and to formal reasoning, and that's the problem. So either we accept the idea that we have some machines that can predict behavior, but their behavior is not understandable, okay? Or we stay with the classical conventional systems engineering only. That's the dilemma, I think. There are things that cannot be formalized, simply. And privacy, in particular, cannot be formalized. But security also, I work on security. Security cannot be formalized. Of course, you can formalize some aspects of security, but you cannot figure out all the possible attacks an intelligent human can imagine. Okay, safety is a much simpler problem because you deal with physics and physical phenomena. So there are things, and this shows the limits also of the rigorous approach.
So we are now time-wise rolling into the Q&A, but I would like to keep it as an open discussion as we currently have. So I'll occasionally throw in a question. Building on what was just discussed, taking it right off Slido, in your opinion, should there be limitations on which decision algorithms are allowed to be created? Which ones and why? Let's start on an easy one.
What do they mean by algorithm? Because now, for instance, machine learning, they talk by algorithm, but there is a big difference between what people call algorithms in machine learning and algorithms in, algorithms that you can program. Because you have two distinct computational models. You have conventional computing, computers that you can program, and computers you can train. And you cannot talk about algorithms in that case. Some people abusively use the term algorithm, but these are not algorithms.
Yeah, I would hazard to guess the answer to that question is no. How can we say there's things you shouldn't study? It's maybe there's things you could study and decide not to deploy, but it's hard for me to imagine something that is forbidden to study. I can't imagine that.
Efim, I guess you agree, judging from the smile?
Yes. Yes.
Excellent. Then, touching upon a point which we did not prominently address yet, what is your view on the social impact of the increasing use of ghost human labor in data labeling and curation? So, where we see basically sweatshops, digital sweatshops arising again in certain regions, labeling data for use in other regions. Any thoughts on that?
I haven't seen the article. What we used at Berkeley and when we're doing the machine learning work was the Amazon system. It was Mechanical Turk, I think is what we used. And I think a question is whether, what do you think of that? People working part-time, making money, is that a good thing or a bad thing? We get accused of job destruction in information technology, that, we're replacing people's jobs with robots. I mean, Mechanical Turk was an example of giving people a chance to do something useful and make money at it. So I have a hard time, when you call it digital sweatshop, that sounds pretty bad. But I guess I'd like to see what the alternative is. In the countries where these so-called digital sweatshops is there devastating poverty in these countries, and this is letting people earn a living and supporting a family and stuff like that. So I think to be against the idea of human beings labeling data would be a pretty strong statement. But I'd have to see the situations. I think we went through that for the smartphones when we talked about the manufacturing sites in China, and I think it eventually led to people inspecting those manufacturing sites and upgrading both the salaries and the working conditions and stuff like that. It kind of ties into what Josef talked about government regulations, right? And things like that. So I don't think necessarily humans labeling data is a terrible side effect of machine learning. It's done right, it could be an upside.
So
But
if we, yeah,
this
go for
yes,
it.
this kind of work, I mean, is you have this type of workforce to test the circuits, for instance. Or in the past, I remember they were testing circuits in Taiwan, for instance, using microscopes or electronic microscopes to see if there is any flow, etc. And this also was a very tedious work. And yes, so this happens everywhere. Yes, I have no opinion about that. Just people
But
have money. Yes. Yes.
but one difference that in labeling data, I don't say that it's done this way, but you could do it at home. So you don't have to be in the factory looking at chips. So there's something wonderful about it in terms of distributing work to people who cannot get out of the
Perhaps.
house for one reason or another. Yeah.
Perhaps if the comparison makes sense. Yes. Okay. Yes.
Well, Shafi, I guess that argument can also be spun the other way around. So if we, like, even zooming out from our particular use case, machine learning and data labeling, one of the things we're enabling with IT technology is ubiquity of work. So the classical idea that you have a distinction between your work life and your leisure life starts to disappear. Any thoughts on that? How do we handle that? Or does this basically bring us back to, well, then we need to update regulation because we also manage to regulate workplaces?
Maybe we should automatically turn everybody's computer off at 6 o'clock. I mean, yeah, that's a problem. The pandemic has really brought it front and center, that there's no difference between day and night and weekend and daytime and holidays because we're all stuck in the same place. I don't think that's a technical problem for us to solve. Us as mathematicians or computer scientists or engineers, it's a much, the fact that we're enabling people to work while they are taking care of their children or their elderly parents or themselves are elderly, that's only a good thing. Now what do you do with the fact that you should take off your pajamas and put clothes on in the morning? There's a limit to what we that we know better than anybody else.
Yeah, I'd like to, there's upsides to our technology. So let's give me a specific example. So there's, cloud computing I think is the future of the data center. A specific example is this company called Zoom. And in December 2019, they had about 10 million users a day, which is pretty cool. In February, they had 200 million users a day. And in March of 2020, right in the middle of the pandemic, they had 300 million users a day. And a lot of us were able to keep our jobs because we could do our jobs via Zoom at home, kind of remarkably. It worked. How did they increase their customer base by factors of 20 or 30? They were using the cloud. They were using Amazon Cloud, and the cloud presents this illusion of infinite computing. And they got more customers. They just asked Amazon. They were able to do that. And so, had that technology not been there, and I think there was kind of this surprise that the internet kept working, right? But we kind of, as all over the world, we went from commuting to work. And that was something you just had to do because you couldn't trust people to work from home, to everybody working at home, and it just flat worked. And our technology enabled that. It also, but there's no, it takes self-control. When I hear some of these studies, I'm an older person. I remember when I was growing up, people were fearful that television was going to destroy society. And it was up to parents to put limits on how much television their kids watch. Today, people are acting like it's not the parents' responsibility to control their kids' use of cell phones. It's like the cell phones are evil. It's the cell phone's fault, and the parents don't have the responsibility of controlling the kids. And I kind of, as an older person, I don't buy that argument at all. I think it's the parents' responsibility to control it. To pretend that the parents are parents can act. You can claim you're not capable of controlling your kids' behavior, but if you do that, all kinds of bad things are going to happen. I don't see why cell phones are necessarily tremendously worse than televisions were when I was growing up. So I think, we're going to need either do self-control or that, I keep track of how much stuff I do online. I have a calendar and I put big blocks, don't schedule me anything in there to try and do things with my family and stuff like that. But it's, we've enabled a lot of wonderful things and there's excesses, but I don't see how we can prevent it. It would have been better off for Zoom not to have been able to handle it. I think it would have been terrible for society if Zoom hadn't succeeded.
So following yeah, go for it.
Yes, I agree, but okay, so the danger for watching television or using phones is minimal. I mean, it's not, I think the danger can come from increasing automation of processes and increasing use of autonomous systems. So for me, a very important question is how we strike the balance between say, humans, the division of work between humans and machines. That's a very important question. So if for instance, you have perfect machines that can do whatever you want, you have a kind of very intelligent slave that can fulfill all your wishes. Would we accept this? How would you feel as a human, okay? This is, of course, this is a theoretical question, but this is a very important question. To what extent we allow this use of autonomous systems? Because what you think, it's not using autonomous systems is not like, of course, technology has transformed humans since the early man times. We lost skills because of technology. That's clear. But the problem is that now we have machines that become intelligent and can replace what is the essence of humans, that is our mind. Okay. So to what extent we will accept this replacement of humans by machines? I mean, this is a theoretical question, perhaps, but it raises some ethical issues.
Okay, we have 2 minutes 20 left, and the highest ranked question, I'm not sure whether it's answerable in one syllable or if it needs hours, but I'll still try. Can data be truly anonymized?
Well, it depends for what purpose. Sometimes you have to cross-reference data in order to get value out of it. So, say you're in a medical context or maybe genetic context, and there's very few examples, so you cannot hope to have sort of the statistical nature of it take over and not look at individual data. In which case, even the conclusion from looking at data will reveal something about the particulars of the data. So I would say that depends on the context. Sometimes what you're trying to derive out of data, it by itself implies something about the holder of the data.
Does anyone want to add to that? Okay, it seems we have an unanimous depends. Excellent. We are slowly but surely timing out. I'll dare myself to try to summarize some of the key insights, at least I'm taking away. Namely, it doesn't all have to be doom and gloom. There are challenges ahead. The challenges should not only be placed on the scientists and engineers, but there is a sort of division of powers between what is scientifically interesting and thinkable, between what governments and societies have to regulate and make of it. And, well, what I actually admire about David's contributions is maybe we should also just remember to stay positive and, yeah, try to be better and do good things. And then Hopefully it's going to be fine. I want to thank all of you very, very much. I had fun. I hope you had too. And yeah, enjoy the rest of the Heidelberg Laureate Forum in digital format. Thank you.